Hey everyone, today we're doing another first order linear differential equation problem. So today our problem will be a little different actually. So here we have a problem that says solve the initial value problem. So what is an initial value problem? Well, it's actually really simple, and it's basically just solving the differential equation as we did in my last videos. But this time we have an initial condition given right here, and this will help us get a more precise general solution, since we'll be able to solve for that C. So in the last example problems we had an arbitrary C value at the end, but this time the initial value will help us give a value to the C. So let's go ahead and get started on this problem. So I'm just gonna bring this down like I did before so we can take a look at it while we work. So here we have our first step, which is to check for standard form. And as usual, if you recall, standard form is y prime plus p of t, y equals g of t. And we can see that this is not in standard form, so not standard form. And we just have to go ahead and put it in standard form. So actually, we have to do two steps here. So first, our y prime has a coefficient of x. So we're going to go ahead and divide everything by x to isolate that y prime. And we're left with y prime equals x to the negative 1, y plus x sine x. We also have this x and y term, this y term right here on the right side when we really want it on the left side. So like here, we have the p of ty on the left hand side, not on the right side. So we're going to go ahead and move that there by doing subtraction. And we end up getting our final standard form of y prime minus, I'm going to go ahead and make that a 1 over x. A 1 over xy equals x sine of x. So this is our standard form, and we can go ahead and do the next step, which is to find the integrating factor. So finding the integrating factor means we have to do this calculation right here. So our integrating factor is e to the integral of p of t dt. Same old stuff. And we know from above that our p of t is this guy right here. And we'll just go ahead and plug that in. Oh, actually, everything should be in x's, not t's. Okay, yeah. Let's just erase these guys because these should be x's since we're dealing with x's here. So keep everything consistent, the d of x. And we'll just go ahead and integrate that. And then we end up with e to the negative ln x. So this is a little tricky, and you might end up thinking that this equals negative x, but that is wrong, because here we have, well, you can think of this like e to the ln x to the negative 1, because there is a 1 right here, and according to the log rules, this is also the exponent. So if you think of it like that, you can go ahead and write it out like e to the ln x, which is equal to x, and the negative 1 stays up there, so you are left with x to the negative 1, which is equal to 1 over x. So this is our integrating factor. Now that we have our integrating factor, we can multiply both sides of the equation, and our equation, if I recall, is y prime, we're just making sure, y prime minus 1 over xy equals x sine x, yeah, x sine x. So we're just going to multiply both sides of this equation by 1 over x, 1 over x, and we get 1 over x y prime minus 1 over x squared y equals sine x. Now that we have multiplied both sides, we can go ahead and integrate. So I'm just going to write everything down again, but in pink. 1x y prime minus 1 over x y prime minus 1 over x squared y equals sine x. Integrate everything. Usual by dx. Now we just go ahead and integrate, and as usual, like I said in my last two videos, my last two examples, this left-hand side is always going to be equal to the integrating factor times y, so that is integrating factor, which is 1 over x, y, and we just integrate the right-hand side, which is an easy integration, which is basic trig integrations, which you should know is just negative cosine x, and don't forget to add the c. So now that we have integrated both sides, we can go ahead and solve for y. I'm going to move this up a bit so we have a little bit of room. And we just go ahead and solve for y by multiplying everything by x, because we want to isolate this y. So we multiply everything by x, and we get y equals negative x cosine x plus cx. Now we are not done, because remember this is an initial value problem. So we have an initial value of y of pi equals 0, and this will help us solve the c right here. So we just have to plug in pi and solve. So we go ahead and do that. So y of pi equals 0, so when x is pi, y is 0. So we make the y 0, and we just plug in pi for all of the x's. Cosine pi plus c pi. And we just solve. So cosine pi is just negative 1, and we have a negative pi here. So negative pi times negative 1 plus c pi equals pi plus c pi 0. Running out of room, and then we can just move the pi to the left hand side, and we get negative pi equals c pi, and divide everything by pi, and we get c equals negative 1. So now that we know what our c is, we can plug it into this above equation right here. So I'm just gonna erase this c and replace it with a negative 1 to save some room. And yeah, move. So when we plug in that negative 1, we just get negative x, and we can say done instead of not done, because this is now our answer using the initial value problem and the initial value, which help us get rid of that arbitrary c, and now we have a more precise general solution.